Equation number 3, 1 over f equals 1 over 0 plus 1 over I, solving for f. This one's a bit tricky, so let's work through this one. Pardon me. One over f equaling 1 over O plus 1 over I. Now, because f is in the denominator and we're solving for f, one easy thing would be to take the reciprocal of 1 over f and turn it to f over 1. Now, to achieve that, we are going to take the exponent -1 of the left side and take the exponent -1 of the right side. Now, most people think that if we take the reciprocal of the left side, it's f over 1, and you'd be correct. But if we take the reciprocal of the right side, most young mathematicians would assume that it's O over 1 plus I over 1. And this is where the big mistake happens, because this was incorrect. And let me just show you why. If you'll remember binomial products, if we take A plus B and we square it, it does not happen to turn into just simply A squared plus B squared. If we take a binomial square, it's going to be AB times A plus B, and you'll remember FOIL, first insides, outside last, and what we do get is A squared, and yes, we do get B squared, but we're missing that AB plus AB middle term, which is A squared plus 2AB plus B squared. So we're missing this middle term. This is effectively the same thing here. If we just simply take the reciprocal of the left side, which is a single fraction, it will work out properly. But if we take the reciprocal of the right side, which happens to be two terms, we're missing a term when we take the reciprocal. So we can't just flip the right side as well as the left side because of the two terms in the right side. So we can't do that. So rather, if you wanted to do something like that, what we would have to do is turn the right side into a single fraction. And that's relatively easy, so we can try that by simply looking at the denominators and grouping these using a common denominator. And the common denominator is OI. And to achieve OI for 1 over O, we're going to have to multiply the numerator and the denominator by the letter I. So this works out to be 1I. Here, to achieve OI for the denominator, we're going to have to multiply the denominator by O, but also the numerator by O. Right? In both cases, I over I is 1, so we're effectively multiplying 1 over O by 1. And O divided by O is effectively 1, so we're multiplying 1 over I by 1. Now that we have a common denominator, we can group the numerator and put it over the one common denominator. Okay. And because of that, we can now take the reciprocal of this side, and we won't be missing any terms because we don't distribute it. So it works out to be f over 1 equaling OI over 1I plus 1O, which is effectively f. F divided by 1 is f, equaling over 1. And the 1 is not necessary. The coefficient 1 is not necessary. It's like saying you have 1 times 1, sorry, you have 1 times 1 cat or something like that. So we can simply write I plus O. And that's our final answer. F equals OI over I plus O.